Hello students, today we will be learning some of the neat questions which has been got from the previous year's question papers. Okay, so this is the question which where we have got it in 2019. Okay, 2019 IIT and Neet. Okay, so what is the question here given? It is sp3d2 hybridization. What is this? sp3d2 hybridization is not displayed by which of this following. Okay, so where you will not see the sp3d2 hybridization. So first we will check it with each of the compounds. So bromine. So there is a shortcut to find out the hybridization. So first we need to know the valence electrons for bromine. So it is present in 7A group, so the valence electrons are 7. So write it as 7 electrons. Okay, so 7 electrons. So each with fluorine. Fluorine, its valency is 1. That means it will be bonded with 1 electron. So fluorine, 5 fluorines are there with 5, right? So this are left alone. So this is 1 fluorine there. So first it is written as S. Next is P. Next is P, T, D and D. So what is the hybridization for this? sp3d2. Okay. So next is what? S sub 6. So sulfur. So sulfur, its valency is 6. So 1, 2, valence electrons are 6, 3. Okay. So each with 1 fluorine. Each with 1 fluorine. So next it goes as S, P, 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 D and D. So again what it is, the hybridization is sp3d2. Again that is also same. And next is what it is given, chromium CrF6 minus 3. Right? So chromium, its state will be plus 3. So minus 3 means what? You will be adding again another 3 electrons. So total how many? 6 electrons. So chromium 6, 1, 2, 3, 4, 5 and 6. So each with fluorine. Again each with the fluorine. So what do you get? Again this also S, P, 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 D and D. So here what is the hybridization? sp3d2. Right? So now phosphorus PF4, PF5. So phosphorus, how many number of valence electrons? 5. 1, 2, 3, 4, 5. So each with fluorine, 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 fluorine and fluorine. So S, P, P, P and D. So now here what do you see the hybridization? sp3d. So which will not be showing the hybridization, that is PF5. So this will not show you sp3d hybridization. Okay. So this is what. So next question, it is also a IIT question. Okay, we will see how it has been going over here. Okay. So how it is. So what is the question here? Which of the following is the correct order of chlorines for the given compounds? Reactivity of chlorides of given compounds. So what happens here it is. So these are the 7-membered rings, right? 7-member ring, 5-member, 3-member, 5-member, 5-member. So when this here, what happens here it is, for suppose if I remove chlorine, okay, so what it is, if I remove chlorine from here, okay, so I'm removing chlorine. So what happens here, that structure will be getting like this, right? This will go like this. Here you will be getting a cation. Okay, this is a carbocation. It is a carbocation. 7-membered carbocation. Again here also a carbocation. Here also a carbocation. Here also minus chlorine. You are removing chlorine. So whenever it is removed as chlorine, it will goes as Cl minus, and here it will be remained as plus. It will be remained as plus 1. So here again Cl you will be removed and you will be getting like this plus. Okay, so this is what. So now we have to write the order of this. We have to write the order of this. So as it is given here, these all are the carbocations, right? So reactivity of chloride. So we have to remove a point is reactivity of chloride is directly proportional to stability of carbocation. Stability of carbocation. So as first carbocation here, this is the first carbocation, right? So this is the first carbocation. As this first carbocation is very stable, it is very stable. First carbocation is very stable because of its aromaticity. It is having high aromaticity. So that is the reason it is having aromaticity. It is having higher aromaticity is high. So that's the reason its stability is high. Okay. So first one is very high. Next it goes to 3. Okay. Third carbocation is also more stable. Is also stable, but less than the first one, less than the first carbocation. Why? Because here delocalization of electrons takes place. Delocalization takes place. That's the reason after the first it goes to third one. Okay, third. And next, if we talk about second carbocation is least stable. What? Second is least stable. Why? Because second is least stable. Why it is least stable? Because it is anti-aromatic. What it is? It is anti-aromatic. So that's the reason it's very least stable. You have to keep it this in the mind. And next, if you see fourth and fifth, that means these two, fourth and fifth, if you see, which is having more stability, fourth. Okay, obviously fourth, because it undergoes resonance. This undergoes resonance. So that's the reason it is more stable. So now what's the order you will be getting? This is what the order. This is the correct order. Okay, so here what is the concept we are mainly looking after? Reactivity of chloride and its a carbocation stability. And we have to check it whether it is aromatic, anti-aromatic, and which is going under resonance. Okay, these 3 points you have to remember whenever you solve such type of questions. Okay, thank you.